Okay, so let's talk about scalars and vector quantities in physics. It's pretty important that you know the difference between the two and see some examples. So as you watch this video, you should work along with the worksheets that were provided with you. So you can pause the video and then jot down information and complete that paper, and make sure you put your name and turn in the paper when you are done, so to show that you have accomplished something. And at the end of this lesson, you should be able to know the difference between the two and be able to identify four of those physical quantities that we're going to use in linear motion. So scalars and vectors. So what is a scalar quantity? So scalar quantity are quantities that has magnitude, which is size, and some numbers, and unit in particular. So some of the examples that we could have would be this one. And this matches a physical quantity in physics. So this one gives us mass, this one's gives us distance, this one's gives us speed, and this one gives us time. But we're going to focus on two major quantities that is involved in the description of motion, and a few stuff right here. And that is distance. So we're going to cover this two on majority of our topic, which is distance. So this two here, we're going to cover those. And we're going to see the difference. We're going to see some examples. And you here, you can already see that scalars only has this and that. And it doesn't give us any information as much. Only this one here. Nothing else. That is scalar. So only the number and the unit. And that's it. Nothing else. However, vectors are a different type of quantity. So they are the ones that give us a little bit more of information. So vector quantities have both magnitude and direction. So give us a concept of a direction. So right now, the only direction that we have discussed are direction that is moving towards and moving away. So you notice that when you did the activity on walk the graph, you were able to notice that moving away is positive and moving towards is negative. So we'll settle on that as we describe. Although you'll see some units of direction, some quantities of directions that are different, such as it uses the cardinal direction north, east, south, west. So we could also refer to that. We know that north is positive, south is negative, east is positive, west is negative. So that's what we're going to use too. You're going to see that as well in some of the problems that we're going to be talking about. So these are some examples of vector quantities, and these are some of the units that comes with it. So most of you probably know the first three. We haven't discussed some of those, but we're gonna focus on this two in particular. Don't worry, we're going to cover this as well. So we'll just start with this two. We're doing one step at a time. So an example of a vector is displacement. So it gives us a number, unit, and more importantly, it tells us a little bit of something. So there's a story behind here other than just knowing number and unit. It tells us that, hey, this object have covered and it's going east. Oh, this one is moving this fast and it's going northwest. And this one, negative acceleration means, oh, it is probably moving towards me. And which unit is meter per second per second. So take note, this is technically different with velocity. But don't worry, we're gonna get into that as we move on. So those are the two differences between scalar and vector. Hopefully you're able to jot down the information in your paper. And let's move on into two of the best type of scalar and vector in linear motion that we're going to discuss. So let's begin with distance versus displacement. So again, distance is a scalar quantity and displacement is a vector quantity. And we should be able to see the difference, a big difference between the two. Although there's some similarity within these two, and that is the magnitude and the unit. Otherwise, they technically are different in terms of describing them now in physics. So distance is a scalar quantity, as I've said. It refers to how much ground the object has covered, and that's pretty much it. So for example, a runner covers 500 meters, nothing else. It doesn't give me any more information. Your school bus travels 20 miles to school. Yes, I know it travels, but any other things that I know? Nothing else. So that is in terms of distance. So the symbol for distance would be lowercase d. And in order to write the problem in terms of the equation, so we would just write down d is equal to the path length. So that's kind of like, I will just add the sum of the first distance, the second distance, the third distance if there is, and so on and so forth. So technically I will get the sum of all the distances, and it's always absolute, so it don't matter. It don't matter if you're moving to the left or to the right. We don't even want to talk about those because we're just knowing how much ground you covered. So that is in terms of distance. So what about displacement? Displacement is a vector quantity again. So it gives us an idea that we are going to look at the overall change of position. So we're always going to refer from where you have started the motion. So how far out of place the object is. So for example, so you have an example here, and we're trying to find out the displacement of this runner. So the runner covers 500 meters east. So it went east, so that's positive. So it moved 500 meters positive. And after some time, it decided to go back. So in a negative direction. So in that sense, we're going to find out what is going on with the object. So, and using mathematical process, we could solve the object's displacement. So let me write it down here. So displacement is a change. It's an overall change. So we're going to use this little symbol here, the little triangle symbol. And that symbol is from the Greek alphabet known as delta. So delta means change in. So that symbol refers to as change. So it's right here, change. So change in the overall placement of the object. How far out of place? So it's the difference between the final and the initial. So we're going to use the direction. So in this case, the initial is 500 meters, and then the final is 100 meter mark. So 100 meter, and then 400 meters, 500 meters rather. So 500 meters. And knowing that it is now in the negative direction, so we are going to write the word negative 400 meters. Okay. Let's say we know it's going west, so we could say 400 meters west. So we can get rid of the negative if we know where it's going. So, but we're going to get used to doing writing the negative and positive to refer to if it's moving towards us or it's moving away from us. So that's one example mathematically of displacement. So go ahead, pause the video and jot down notes. You watch these videos at your own pace. Just be aware of the time, that there's a time that we'll have to accomplish this task. So let's move now into speed. So what is speed? What is velocity? So speed is a scalar quantity. So it is a scalar quantity that we will be talking about. And let me write it down. So it's a scalar quantity. And velocity is a vector quantity. So it has direction. So plus direction. So we're going to add positive, moving away, and moving towards the observer. Okay, away. So speed has a symbol, lowercase s. S is the symbol. So my apologies for a little bit lagging. So that's the symbol for speed. Okay, and we can also have a symbol for average speed, and we will just put a bar on top. So for velocity, the symbol is lowercase v, so that's for velocity. And if we put average, we will just put a bar on top. Or sometimes you will see a v lowercase and they'll put the word average, the abbreviation for average. So what are some examples of speed? Speed, 5 meters per second. So the best thing to understand speed is, if you probably have noticed in your parents' car, in the dashboard, there is a speedometer. So the speedometer is named after the word speed because it only tells us how fast. So the definition of speed is how fast the object is moving. So how fast the object is moving. So how fast the object is moving. And this tells us that the object is moving that fast. We can also put 10 kilometers per hour, some units, or 8 miles per hour. So there's a difference if you're gonna write this down. So you could also write it meters per second. Okay, those are some units. What about velocity? So velocity example would be 5 meter per second going to the right, or 10 kilometers per hour going left. So it gives us an idea that it is going somewhere else. So what's the definition for velocity? So velocity tells us how fast and where it is heading. So where is it going to? So where is it going to? So that is what is meant by that. So I know it's going that fast and I know where it is going by adding direction. So the mathematical equation for speed and velocity are this. So speed is equal to the ratio of distance over time. Same thing as velocity, which is distance over time. And we will just add direction. So you will notice here that this is a physical quantity. This is a physical quantity, time and distance. So speed and velocity are usually called derived. So derived quantities. So derived quantities means they are taken from other physical quantities and then they were combined to give meaning into it. So these quantities that were taken, these are called base quantities. So these are base quantities. So you're also learning another quantity here. So you have a base quantity and then you have a derived quantity. So base quantity only has 1 unit. Only has 1 unit. Derived, you will notice there are 2 units. So the unit for speed would be meter per second. The unit for velocity would be meter per second, and then going left. So we will always add direction. And that is about scalar and vector quantities. So do not forget to complete your paper and turn it in when you are done.